Hello everyone. A very good afternoon to all of you. My name is Priyesh, and let me introduce to my team, Mr. Aditya Singh and Ms. Ayushi Pal. We are research scholar from Indian Institute of Technology, Patna, and today we are here to present a seminar on a research survey carried out by us under the guidance of Dr. Ajay Mondal. So this research survey is about energy theft detection based on the anomaly detection pattern. So let's see what we are going to see today in this presentation. The first part will be introduction, which will be given by Ms. Ayushi, and she will also discuss about the problem statement that we are going to solve in the future. Next part of literature review will be presented by me, where we will discuss what had been happened till now in this area of research. And after that, the most interesting part will be presented by Mr. Aditya Singh. He will discuss what is the current trend that is going on and what is the future in this technology. And finally, the references will be given. So I transfer my controls of PPT over to the Ms. Ayushi. She will discuss the introduction portion. Ayushi, over to you.
Thank you, Priyesh. Now comes to the introduction of energy losses. So what do you mean by energy loss? Energy loss occurs when energy is transformed from one form to another, or moved from one place to another, or from one system to another. There is always an energy loss. This energy loss may be in the form of heat, sound, or maybe in any form. So basically, here we are discussing the energy losses occurring in the electrical system. There are mainly two types of energy losses. First one is the technical loss, and the second one is non-technical losses. Technical losses occur due to technical losses occur in the distribution network due to the cables, transformers, or substations where we are transferring the electricity. Non-technical losses occur due to the misallocation or inaccurate usage of energy. This may be occurred due to fraud or theft or billing problems. Now, what do you mean by electricity theft? Electricity theft is the intentional and illegal usage of electricity by various means, or when we are going to pay the bill less than the electricity used. It can be accomplished by physical tampering, such as unjustified changes to the meter, or by electrical tampering with the meter data in the smart meter network. There have been many techniques developed to detect the energy theft, but to detect the energy theft by using machine learning or deep learning methods like classification methods like support vector machine, k-nearest neighbor, or deep learning methods to predict the normal and illegal usage of electricity. But there is a problem in classification method, that is the lack of attack data. Now, what do we mean by lack of attack data? Like we are having the 200 users which who are using the electricity legally or illegally. Now suppose 195 users are using the electricity legally and the 5 users are using the electricity illegally. So there is so we are having the data only of 5 users, which is very less. By only this much of data, we cannot predict whether there is electricity theft or not. So this type of problems may occur in classification method. Next slide. Now, what do you mean by anomaly detection? Anomaly detection means a deviation from the normal. Like this is a method which is used to detect something which doesn't fit in the normal behavior of a data sheet. Anomaly detection or outlier detection is the process of identifying rare items or observations or abnormalities from the rest of the data. Those unusual things which occur in the data are known as the outliers or peculiarities. There are mainly three types of anomaly detection techniques: supervised anomaly detection, unsupervised, and semi-supervised anomaly detection. Next slide. The algorithms used for anomaly detection in machine learning are: first one is the local outlier factor, then k nearest neighbor, and support vector machine. Local outlier factor. This algorithm is based on the local density. It compares the local density of the data with the neighboring data points. If the density is lower than the neighboring data points, then it is considered as outlier. It is unsupervised anomaly detection technique. In k nearest neighbor, we the data points are visualized on the basis of a scatter plot, and the distance is measured, and if the it is suitable for both type of data set, like small data set and large data set. Support vector machine, it is the type of supervised anomaly detection technique. It uses a hyperplane to differentiate between the two classes. Now comes to the anomaly detection. It from the learned area, it clusters all the normal data behavior, and then by using testing schemes, it concludes the abnormalities in the data. Next slide. Now comes to the problem statement for future implementation. Like nowadays, till today, we are having for electricity theft detection, we are using a large amount of data, like for 2 years data, or for 5 years data. So it is very difficult to store that type of data for detection purpose. So because of this, the outliers are detected very difficultly or less accurately. So for so the classification problem becomes very difficult to apply. So because of this purpose, we are going to handle only the real time data, which can make our system very accurate, and can work on it in future. Now comes to the research survey, which will be detailed by Priyesh Saini.
Thank you, Ayushi, so much. Thank you for well-presented introduction. So let's start with research survey. In our survey, we have gone through several papers, and in our findings, we have accumulated some of the best papers, which resulted into a best accuracy. And here we are going to discuss them one by one and see what are their problems associated with them. So in the first one, in the first paper, which is reference number 1, an engineering framework was presented, which is a mixture of financial modeling and genetic programming. This study was basically more focused on finding non-technical losses, which is present in the advanced meeting infrastructure. The second research paper, which is presented by Mr. Huang in reference number 3, suggested an artificial neural network. And artificial neural network is widely used in varied kind of problems. Here they have used IEEE 13 bus system to generate the data, and the data sets, 24 data sets are generated on the basis of and each data set represents each buses repeated over a cycle of 24 hours. So this ANN system and this ANN algorithm can be used in the following way. First way is to separate the entire system into smaller sections, because it will reduce the power, it will reduce the burden and algorithm. So one by one, we can divide into smaller sections, and then can be processed differently. The second way is to divide that power system itself into 3 different parts. As we know, that power system is a large network. It consists of generation system, transmission system, and distribution system. And most of the time, the energy theft problem, which we are going to solve in future, is basically happen in distribution system only. 99% of the energy theft detection happens in distribution system. Therefore, it is wise to differentiate this distribution system from rest of the power system, so that we will get less data, we will get more information from less data itself. And this in turn will prevent the overfitting of the model, which will increase the efficiency and generalization capability of the model. So the same thing was done in this survey, but although the author suggested made a very intuitive approach in handling this problem. No specific calculation was found here, unfortunately, and to use this solution in practical purposes, it needs better criteria to identify the dishonest consumers. In the next paper, Park, which is reference number 1, produced a deep learning model. In this deep learning model, basically they first try to process the data using min-max, scalar, and standardization normal techniques. What this scalar and what standardization does is we are trying to transform the data into similar ranges, because the data set consists of various values which belongs to different ranges. Some of the numbers can be very large value and some of the numbers can be very small value. So that will create a kind of bias in the system, and we don't want that in our model. So basically the author tried to normalize the data, and then it was transformed into one binary stream in the form of ones and zeros, and the output is one when the outlier is detected, and it is detected when it is zero, it represents a normal consumer. So it is kind of like one hot encoding. So here is the table which will give you the brief overview of all the papers which you have gone through, and simultaneously we will discuss about what are the results that we have got in this paper. The first one was FMM clustering algorithm. The accuracy we can see is 68.4% to 81.1%. Accuracy is very good, but as you can see, the computation time required varies from 10 minutes to approx more than 1 hour. So although the accuracy is okay, but computation time is very large, and hence it cannot be used for practical purposes. The parameter which the first paper focused on was accuracy and computation time, as we can see here. The second one is anomaly detection using time series forecasting. Of course, we are dealing with the time series data. So time series forecasting can be used, and the tools which are used here is Keras library, and AutoArema model has been used here using Python languages. And time series forecasting is basically used for future predictions, and the parameter which was focused on was computation time only. Next paper discussed about artificial neural network. Unfortunately, no which data set has been used here is not mentioned in the paper. And as we already seen, they use 13-bus system. It is radial distribution test feeders. And the result, of course, it is a prediction only, and they focused more on accuracy. Next one is detecting the fraudulent consumer from the normal consumer. It is reference number 4. And in this, they have used Irish dataset, which is used mostly in this kind of energy theft detection models. It is very popular dataset used by many of the authors. And in this technique, they have used a combination of k-nearest neighbor and ETD framework. And the accuracy was very good. Accuracy was almost around 88% for k-nearest neighbor, and this ETD algorithm provide accuracy of 93%. And in the final one, the technique used was support vector machines with their accuracy of 95%, detection rate was 94%, and the major parameter which focused here was accuracy only. So after going through so many papers, the generalized format which we have found to build a model is as follows and can be described through this diagram. First of all, the data from the smart meters is gathered and is stored in a server. As you can see, it is stored in a server in the form of raw data. Now, this raw data it contains so many errors because of many reasons. It may happen that smart meters can become corrupt and results into a wrong value. So this might affect our model. So therefore, it is essential to handle those corrupt data and handle those missing values. So this is done in the pre-processing layer. After the missing values are handled, we do the normalization thing. As I mentioned before, normalization increases the efficiency of the system by bringing all the data into similar ranges. After the pre-processing layer, it is now time to do the exploratory data analysis, which is done in 2 steps. First one is data visualization. First of all, we will see what are the features, what is the relation between several features in the data set, and this can be done in the graphical way. We can use several type of plots available in the Python libraries. It can be histogram, it can be distribution plots of many kinds. It can be a bar chart, it can be line chart. So many kind of display, data visualization technique can be used. and then we'll extract out those features which are essential to for our modeling. Of course, there are many more features in the data set, but not all the features will be useful for our model creation. So we'll extract out only the important features that will result in the best prediction. And after that, exploratory data analysis. Now our data is prepared finally, and now it is time to divide the data into training part, testing part, and validation part. So three sets will be created, and the training data will be used for training the as a training in the artificial neural network. Once training has been completed, we will test the output against the test data, and the test is this accuracy of the test data. That means the generalization capability of the model will be measured in terms of various features available, that is RMSE, MSE, R square score, and validation curve. These are the performance metrics that can be used to find out the accuracy of the model. So with this, I complete my part, and now I'm transferring the controls of PPT over to the Mr. Aditya Singh. He will discuss about the next part of our presentation. Aditya?
Thanks, Priyesh.
Thank you.
Thanks, Priyesh, for the giving the information about the literature service and the introduction. Now, I am asking to begin from the how to current scenario, how the future trends are useful for the anomaly detection, and then we start from the some. I am giving some techniques, their advantages and their drawbacks on the techniques, existing techniques. Now, first, when we are starting the techniques, I am giving the three data that are useful in my slides. The first is annotated data. What is the mean by annotated data? This is simply when we are working on the machine learning, they have the required the data for the training and testing purposes. Then the annotated data for the energy consumption, they are simply data is tagging and gives the tag and some information features for the recognition and the detection for the using the help of the computing. This is useful for the annotating data. And the second terminology that you used in my PPT slides, that is interpretability. What is meant by interpretability? This is simply when humans know all the things by their learning, by the experiencing the things. Like when we are child, we are don't know about the fire, but when we are experiencing, then it's a fire, it's a harmful, there's a gives some heating energy. There's a humans are learning by the experience and some suggestion from the others. Same is working in the for the machine learning algos. Then this is interpretability, this is a learning degree, how much learn the data. This is interpretability. When is a higher degree, then accuracy is more. Their learning accuracy is more. Then we are 2-3 types in supervised and unsupervised types of the learning process. They are covering by the IUC, but I am exactly starting the techniques, the Canon techniques. What is in Canon techniques in description there I am taking. This is it means they are calculating the neighbors values of the metrics, and they calculate the taking the average of the metrics and then give the simply clustering info to another things. Then there are many advantages. There is a no need for the annotated data, but it had some drawbacks. They have the low detection accuracy. Means when any deep learning methods are used and they are detecting the exact result is a problem creating. And the second drawback is only these are used in excessive conjunction, where industrial use is possible in their cost. The next technique is time series forecasting. In time series forecasting, they are simply used by the historical background, like they are collecting the previous data and predict the how much data used in the future. And their advantage is they have the low training cost because they are know about the previous things. That's the advantages, but the same drawbacks is they have low detection accuracy and excessive consumption will be detected. And same is a technique in ANN and RNN. When we are talking about the RNN, they have simply analyzed the data from the time series, distance series, and predicted this predicted the values in the when any holiday occurs and when weather occurs, like in summer energy consumption is more, and in winter the energy consumption is less. Then calculating in the advantages are high detection performance, and they have this drawback of the weak interpretability. When we are talking about the SBM is simply a technique they calculating in the 24 hours technique and checking by the previous data, and they have the advantage of two type anomaly is usually high detection performance advantages on this technique. And after that, when you are talking about the drawbacks, they have the lack of annotated data. And next, in the current scenario, the main topic is CNN based, which that the current approaches for the anomaly detection and many field of the deep learning. In there, simply they are calculating the theft. When we are talking about the theft and fraud in the electricity, they have the give how to identify the theft are occurring, how the normal, when simply I was taking an example, when we are giving a normal days consumption for the energy transfer, and how much when any theft are occur, then energy consumption are increases. Then CNN is simply checking the how much data goes, and by the feedback network they are calculating how much data, how much energy is wastage, how much energy is increases. The advantages they have gives privacy presentation, and their detection accuracy is much more better. But we are talking about the drawbacks. They have the more drawback because the high computational cost. Because in implementation of this CNN in the every areas is the huge things for the different ratio, and they had a different only working on the theft and fraud. This is a specific region of the working of CNN. Please turn the next page. And we are talking about the next page. They have the how to collect the data, how to anomaly detection are working. They simply first we are calculating about the energy consumption collection. Simply collecting the data from the every field, like we are working in the energies in giving the buildings, areas, companies, stadiums, and many more are there. Collecting all the energies, all the energy from the appliances or working on electrical connections. After that, we are pre-processing our records where if any invalid records are coming and any noise are coming, then first remove all the things from that. The next process is the feature extraction. How to feature extraction? This is simply extract the average, like they have this mathematical spot. They have the calculating by the average, calculating by the mean, medians, and standard deviations, and so many approaches are there. Equidal distance are there. Then how to calculate their feature extractions? They are mostly used for graph based and density based use. How much density based is, how many people are working, how many people are live in this area, or how many per hour consumption are occurring. That are calculating the feature extraction. Now simply, and we are going for power sampling, and they are completely simply taking the how much normal data is working, like when any simply normal things are occur, like simply going to electricity, and how much data is occurred when in abnormal power. In abnormal power, when any theft and fraud occurs, that is taking there and taking a level, taking a level from the data. In learning mode, they have different types of neural networks and deep learning classification, and many methods are working on and the current scenario, but the most popular is deep learning and neural network. And after that, anomaly detection are working. They have simply all are talking by the Priyesh and Ayushi. Next page, please. Next page, in I am dividing the two scenarios. They have the what is going on what are the future on their topic on the energy consumption and theft and fraud. As current scenario, they have the three types of collecting the data, and they are annotated in the deep learning. In the first is considering from other data. They simply in first thing how much normal data is going, and what is occurs if any theft occurs, like when in we are establishing 1 meter in every buildings, like and giving the specific meters, sub meters for the appliances, like how much like AC give reduce the energy, how much fan is working for the energy. They are giving some meter for every appliances in the home, and then calculate the average power, average meter rate, and check with compare with the main meter with other sub meters reading and taking average. If any difference occur, that's means is a cheating and the fraud is occurs, and this is working on the considering data. When we are talking about the non-institutive anomaly detection, they have the simply did not install sub meters for the every appliances, simply calculating the power reading of the all the appliances and how much appliances are consume the energy when it's working, then comparing all the readings, and it simply gives one feedback network of the all appliances to how much going the energy consumption and how much required for the energy consumption. Then after that, a collection of annotated data set, simply they have divided into two types of data set. They have completed by the two sections. Then it's covering 6 months. One is 6 month average data is recorded, and in another hand is 2 years of average data recorded in a specific area and specific ranges. Then compare all these things and decide their theft and fraud is occurs or not. After then, in new perspective, their deep learning occurs. They have the some challenges on the deep learning based models. The first challenge is we're talking about the this is a black box property. This is a like black box property totally told us when in all the things in deep learning are talking about in the only theoretical layer and software level, but we are implementing when in a practical method, then it's a create a very complexity, and they takes a lots of computational cost for the implementing all the things. When second challenges like is the when this is working, we are talking now that fraud and depth in abnormalities are occur in the data, but is simply going tell this is how to recover, how to got the fraud, how to get any one of the theft are working or not. But it's a real time scenario we're taking. There's a critical problem in deep learning how to theft is occurs. But sometime it's occur how to simply collect the data from the deep learning. Simply is implanting microcontroller. They are collecting the data and collect its data gives connectivity and upload to the cloud, and how much data is worker because when we are working in 2 years, 3 years, 4 years, 5 years, then check the all the data, then it's give the more required more memory. That's why it's useful to upload data in clouds. And when in third party deep reinforcement learning, they had the simple algorithm. They say you how to trial, how to working are the parallel reception of network. This is sufficient for the learning process. And then when we are at the end, how to check my project, how to check my data requirement, that I like my methods are good or not in the deep learning of the energy consumption. They how efficient are our project, how efficient not. They simply have two types of they are checking. One is a precision, how much precise value of the my project of the deep learning, how the deep learning working is the precise value. How to check precise value is simply two types. They are taking by the averages of the values. In they have true points, they have the false point. If the detection is theft is successfully covered, this is a true point. If detection is not covered in the real time before the implementation, this is not covered. They're dividing the sum of these values is give the precision, and same as they give the recall value for the dividing of this. And our all the things when we are talking, they are simply I am giving one liner for the energy congestion in the anomaly detection for the uses approaches of deep learning. This have the when we are talking the abnormal data, it's a good if you take previous data, but it is not useful for real scenario because it give the very problem critical problem and implementing problem occurs. When we are talking about the normal data, like when any thefts and frauds are not occur, simply we are going how much data is sending and how much recovering from the feedback network. There simply work is very useful, but it's not in the abnormality data. So I am requesting to Priyesh Saini, please wind up the project survey.
Thank you, Aditya. Thank you for your wonderful presentation of this current trends. Ayushi and me focused on, Ayushi discussed introduced us to the topic of anomaly detection, and I discussed what previous work has been done, and most importantly, what is the future of this field in the area of energy theft detection is discussed by Mr. Aditya Singh. So now we are winding up the presentation. I thank you for my teammates. I thank you to my teammates for their continuous support in making this possible. And I thank Mr. Dr. Ajit Mondal sir for their support throughout the study of these papers. So we hope you like it, and thanks for your support. Thank you.
Thank you.
Thanks, everyone.